Dear children, in this session we will learn how to use the concept of definite integrals in order to find the area bounded by some of the curves. Now see some of the examples I have taken from exercise 8.1 from the textbook. This one says find the area of the region bounded by the ellipse x square by 16 plus y square over 9 is equal to 1. If you look at the equation of the ellipse, you will see x-axis is the major axis and y-axis is the minor axis, and we can easily make out the vertices of the ellipse. Now because we have to evaluate the region which is bounded by this entire ellipse, so you can see that is being denoted by the shaded region. Okay, and moreover you can see the ellipse is symmetric about the positive and negative x-axis. If you see the axis of this ellipse is the x-axis, so the entire ellipse is symmetric about it. So instead of finding this entire area, if we evaluate the area which is enclosed in the first quadrant only, then 4 times that will be the entire area which is bounded by the ellipse. So instead of evaluating this entire area, we can go for finding the area which is enclosed in the first quadrant only. So let us see under what limit this is to be integrated. Now if you see the endpoints of this part of the ellipse, and from these endpoints if we drop perpendiculars on the x-axis, this perpendicular meets the x-axis at origin. The other end is already on the x-axis and it meets it at 4, 0. So from 0 to 4, we are going to integrate this curve. So required area can be written as 4 times, because we have to evaluate the entire area, so we are going to multiply this with 4. So 4 times the integral within the limits 0 to 4, and because you are taking limits in terms of x, so the curve should be written in terms of x. So we are going to simplify this equation and we will write y in terms of x. So y coordinate of ellipse we have to write in terms of x. Now on converting y in terms of x, this will reduce to 3 by 4 times square root of 16, which can be written as square of 4 minus x square dx. So 4 and 4 here gets cancelled out, and this can be integrated using the formula for integral of square root of a square minus x square. Applying the formula, it will take the form x by 2, then square of 4, which is 16 minus x square, plus square of a, that is again 16 divided by 2, sine inverse x over a, and a over here is 4, and the limits from 0 to 4. So we are going to first replace x by 4, and when we do so, the first part reduces to 0, because square of 4 will be 16 and 16 minus 16 will give us 0. So this term is going to vanish on replacing x by 4. Now moving on to the next term, we can divide 16 by 2. It comes out to be 8. And then we have sine inverse x over 4, and x is equal to 4 only. So this is 4 over 4. Then minus, now we are going to apply the lower limit, which is 0. If we replace x by 0 here, this reduces to 0 only, because 0 into 4 it will reduce to, that comes out to be 0 only. And even in the later part, sine inverse 0 is also 0. So on applying the lower limit, the entire expression reduces to 0. So now we have 3 into 8, which is 24, times sine inverse 1. Now sine inverse 1 can be written as pi by 2. So you can see with 2 we can cancel out 24, and the area enclosed is 12 pi square unit. Because we are dealing with area, so don't forget to write square unit. Now taking the next one. Next one is find the area of the region in the first quadrant enclosed by x-axis, line x is equal to square root of y, and the circle x square plus y square is equal to 4. So first look at the curve. Circle can be easily plotted because we know its center will be at origin and the radius is 2. Now, in order to plot this line, you should first know the point of intersection of these two curves, the line and the circle. Once we come to know the point of intersection, the line can be easily plotted. So you can see this is the equation of circle, and equation of line is given as x square root, x is equal to square root of 3y. So y can be written as x over root 3. So this value of y you can substitute in the equation of circle. So whenever you are finding point of intersection of two curves, you can solve both the equations simultaneously by putting the value of one variable from one equation into the other one. So we are replacing y by x over root 3 in the equation of circle. So we get x square plus x square by 3 is equal to 4, which further gives us on solving x is plus minus root 3. So if x will be plus root 3, then y will become plus 1. If x is minus root 3, y will become minus 1. So you can see one of the point I have already marked here. This point of intersection is square root of 3 comma 1, and this one will be minus square root of 3 comma minus 1. So when you roughly mark these 2 points, you can join the points and the resulting line can be formed. Now once the line is being done, we will again see what is to be evaluated. They are only asking us to find the area which is enclosed in the first quadrant by x-axis. So one boundary of the area enclosed should be x-axis, one should be the line x is equal to square root of 3y, other should be the circle. So if you see clearly, this part of the line and this arc of the circle and the x-axis, they are forming the required region whose area is to be evaluated. You can see the area is being shaded. So this shaded region we have to evaluate. But if you see, the entire shading is not under one curve, it is under two curves. This is the point of intersection. If I of both the curves, the line and the curve, if we drop a perpendicular from here, it will meet the x-axis at root 3 comma 0. So you can see when we move from x is equal to 0 to x is equal to root 3, this shaded region is coming under the line. But from x is equal to root 3 to x is equal to 2, the shading is under the circle. So how are we going to write the required area? Required area will be sum of two areas. Firstly, the area under the line, and the next part is the area under the circle. So the part which is under the line ranges from x is equal to 0 to x is equal to root 3. You can see in the diagram. So between 0 to root 3, the area is falling under the line. So I will write the y coordinate of line here, and then we'll integrate it with respect to x. Now after this, from root 3 to 2, the area is falling under the circle. So we will convert y from the circle in terms of x. So let us do the conversion and then integrate both. So if we look at the line, y in terms of x is x over root 3. See the equation of line, it was x is equal to root 3y. So y can be written as x over root 3 dx we will write here. Then in the later part, which is from root 3 to 2, if we look at the circle, we can write y square as 4 minus x square. Then y will become square root of 4 minus x square. So 4 can be written as square of 2, then minus x square dx. So we need to integrate these two, and then we have to apply the limits. So integrating both first, over here 1 by root 3 we can write outside, and then we are integrating x whose integral is x square by 2. In the next step we will be applying the limits. In the later part again you can use the formula for integral of square root of a square minus x square. So it reduces to x by 2 square root of a square minus x square plus a square by 2 sine inverse a over here is 2. So sine inverse x over a, which is 2 only, within the limit square root of 3 to 2. So now we will be applying the limits. In the first part you can see we will replace x by root 3. So square of root 3 will become 3. So we get 3 by 2. Then we'll replace it by 0, which reduces it to 0 only. Coming to the later part, first we need to replace x by 2. If we replace x by 2 here, this will reduce to 4. And 4 minus 4 is 0. So this part is going to vanish. So we move on to the next part. 4 by 2 is 2. Then we get sine inverse and x is getting replaced by 2. So this ratio becomes 2 by 2. Then minus, we will apply the lower limit now. That is, we are replacing x by root 3. So this will become root 3 by 2, and under the square root, 4 minus square of root 3, which is 3. So 4 minus 3 comes out to be 1, and square root of 1 will be 1 only. So we leave it here. Then plus 2 times sine inverse x by 2. X is getting replaced by root 3. So root 3 by 2. So you can see we have applied the upper limit and the lower limit in both the cases. Over here you can cancel out 3 with root 3. So it reduces to root 3 by 2. Then moving on to the next part, it is twice sine inverse 1. Then if you open this bracket, it is minus root 3 by 2. And the later part is twice of sine inverse root 3 by 2. So we see plus root 3 by 2 and minus root 3 by 2 gets cancelled out. Then sine inverse 1 can be written as pi by 2 plus 2 times sine inverse root 3 is pi by 3. So even here you can see 2 and 2 gets eliminated and we are left with pi plus 2 pi by 3, which happens to be, okay, we will check this part quickly. See, because we have opened the bracket here and there was a negative sign outside, so this part should be minus of twice of sine inverse root 3. So we'll have a negative sign here. So we are left with pi minus 2 pi by 3. So replacing this by minus, we are left with pi minus pi by 3, 2 pi by 3, which on solving comes out to be 3 pi minus 2 pi by 3, or we can simply say pi by 3 square unit. So this is the area which was enclosed by the given line and the given circle. Now taking the next one, it is finding the area of the region which is bounded by a parabola and y is equal to modulus of x. You can see y is equal to mod of x can be written as x if x is greater than equal to 0. It will be minus x if x is less than 0. So we have got this curve y is equal to x square or x square is equal to y. It will be symmetric about positive y axis. And when we plot for y is equal to mod of x, we get this V-like shape. Okay, now if you see, both of them are enclosing this area which is shaded. So we have to find this area. If you see again, the whatever area is shaded in the second quadrant, same area is shaded in the first quadrant also. So we can find the area enclosed in the first quadrant only, and taking twice of that we can get the entire area which is enclosed by this parabola and the line which is y is equal to mod of x. But for that we need to first know what are the points of intersection. So we will solve y is equal to x square with y is equal to x. So if we equate, because they both are equal to y, on equating their right hand side we get x square is equal to x, which on solving gives us two values for x. Either x becomes 0 or it becomes 1. And when x is 0, y also becomes 0. And when x is 1, y is also 1. So you can see this part, y is equal to x, and this part of the parabola, they are intersecting at 2 points, 1 comma 1, and this one is known to you, it is 0 comma 0. In the same manner, if we solve the parabola with the line y is equal to minus x, where x is less than 0, you will find this point of intersection is minus 1 comma minus 1. So let us now write for the required area. For writing the required area, we will first locate the points of intersection, because we are writing the area as twice this area So we will focus on this part only. If you see on this part, there are 2 points of intersection. One is 0, 0 and another one is 1, 1. And if perpendiculars be dropped from there on the x-axis, then you will see this point is already on the x-axis. The other point meets the x-axis at 1, 0. Now look at the curve under which the shading is appearing. You will see the upper curve is the line. So if I write that required area is twice the integral where x ranges from 0 to 1. Okay, so from 0 to 1, the area is falling under the line. But when we say it is falling under the line, we get this required area. We also get this unwanted area which is not shaded. So if I write area under the line, okay, then I'm not getting the area we require. Other than that, we are getting extra area. So we need to see this extra area is falling under which curve. You will find this unwanted area is under the parabola. So from the area which is under the line, if we subtract the area which is under the parabola within the limits 0 to 1, if this difference be integrated, then we will get the required area. So let us write the expression first and then integrate it. Y in this case, if you see the equation of this part is y is equal to x. So for the line, y will be written as x, and for the parabola, you can see this parabola is y is equal to x square. For the parabola, y is x square, and within the same limits it is to be integrated. So the integral comes out to be integral of x is x square by 2, and that of x square will be x cube over 3. And now we need to apply the limits. First we will replace x by 1, then we are going to replace it by 0. You can see if we replace it by 1, we get twice of this reduces to 1 by 2, and the later part reduces to 1 by 3. And if we now replace x by 0, both the terms will reduce to 0. So that we need not calculate. And here we get the result as twice of 1 over 6. If we take the LCM, it will be 3 minus 2, which is 1 divided by 6. So 2 into 1 by 6. That comes out to be 1 over 3 square unit. So this is the area which is enclosed by the parabola, and y is equal to modulus of x. Now taking one more question, it is finding the area which is bounded by the curve x square is equal to 4y. This is a parabola which will be again symmetric about the y-axis, and the line x is equal to 4y minus 2. Now plotting the parabola is easy because it is in standard form, but we need to know where the line will intersect with this parabola. So we will find the point of intersection of these two curves. So one is parabola, another one is line. You can see in the equation of line, we can write 4y as x plus 2. And in the equation of parabola, 4y is equal to x square. So equating both, we get x square is equal to x plus 2, which on solving gives us two values for x. Either x will be 2 or x will be minus 1. When x is 2, y is coming 1. So this is the point. And when x is minus 1, y is coming out to be 1 by 4. So this is the point. So we have located 2 points on the parabola. You can join them and extend so that you get the required line. Now you shade the area which is bounded by both. So you will see the shaded region is enclosed by the line and the parabola. And if we look at the point of intersections and we drop perpendiculars from there, so you will see one perpendicular meets the x-axis at -1, other one meets the x-axis at 2. So we are going to integrate the function within the limits -1 to 2. But how it is to be done? If you see within this range of values which x is taking, the required area is falling under the line. So when we evaluate the area under the line, we get this required area, but we get some unwanted portion also. If you see this part which is unshaded, this is unwanted. This is also calculated when we find the area under the line. And there is some small part here also which is also unwanted, which is getting included in the area under the line. So from the area under the line, we are going to subtract the area under the parabola, because this unwanted region is under the parabola only. So writing for the required area, which can be written as an integral within the limits -1 to 2. You can see here the area in both the quadrants is not same. So we need to solve the entire area as such. Okay, in case equal areas were enclosed in both the quadrants, then we would have solved only one part, and multiplying that with 2, we would have got the entire area. So over here the situation is different. So from -1 to 2, we will write area under the line, from which we will be subtracting area under the parabola. So we will write the expressions in terms of x, whether it is line or the parabola, and then we are going to integrate it. So let us check for the line. If you see, equation of line is 4y is equal to x plus 2. If we cross multiply 4, we will get x plus 2 over 4. So in line, we have converted y entirely in terms of x. And same we need to do for the parabola. So if you look at the equation of parabola, y can be written as x square by 4. So this expression needs to be integrated within the limit -1 to 2. 1 by 4 can be taken common from both the parts. And now our expression is x plus 2 minus x square dx. Now this is what we need to integrate. Now integrating it, we get 1 by 4 times integral of x will be x square by 2. That of 2 will be 2x. And that of x square will be x cube by 3. Now we are going to apply the limits. First we will replace x by 2. On replacing x by 2, here we get 4 by 2, which comes out to be 2 only. Then plus 2 times 2, which is 4. And then minus cube of 2 will be 8. So we get 8 by 3 here. Now replacing x by -1. So square of -1 is 1 only. So this reduces to 1 by 2. Then 2 into -1 will be -2. Then cube of -1 will be -1. So minus of -1 will make it +1. And this divided by 3. Now solving the obtained term, 2 plus 4 here is 6. And when we open this bracket, this will come out to be +2. So 6 plus 2 will reduce to 8. And then we have got -8 by 3. And from here we get -1 by 2 as well as -1 by 3. Now look at these two terms, -8 over 3 and -1 over 3. That will give us -9 over 3. Okay, so first term is 8, then adding these two, which is -9 over 3, which can be written as -3 only. And then the leftover term, which is -1 by 2. So finally we have 1 by 4 times 5 minus 1 by 2. Now 5 minus 1 by 2 will reduce to 9 by 2. So 9 by 2 multiplying with 1 by 4. And we get the required area as 9 by 8 square unit.